Oh, welcome guys. So in this video, this is our final video for Legendre Polynomial. In this video, we are just trying to write down the complex value functions, complex value integral for the Legendre Polynomial. Okay, so this is our answer. This p n to z is 1 over 2 pi I2 to the n, and this is the integration. T squared minus n, t minus z to the n plus 1 dt. And your integration should be counterclockwise and along the z. Enclose the point z. Okay, so remember our starting point will be Rodriguez formula. So in a previous video that we have proved that the Legendre polynomial p and z will be 2 to the n factorial d to the dn dzn z squared minus 1 to the power n. Okay, so this is the previously what we have. Okay, so f of z, right? Our starting is complex value. This is f of z is 1 over 2 pi I, and then we've done integration c. So c is a counterclockwise loop, contains this z, f of t divided by t minus z dt. Okay, and we've just put f of z to be z squared to the n. Then we will get this, right? We will get the z squared minus 1 to the power n. So this just put this equation in. Then we get this one. Okay. Then with differentiation respect to n times, right? Just respect to z and n times. So n factorial comes from here, and there's no minus sign, right? Because there's already a minus sign here. Then the numerator is the same, but denominator will be t minus z to n plus 1. Okay. Then we just take 1 over 2 to the n times n factorial, just the previous this one. Okay. This red one. So then we will get right. We will get start from here and get this. This is the Rodriguez formula. So we put Rodriguez formula here, and then we times this to here. So n factorial cancel. Then finally we get this. Okay. So this is what we want. Okay. So the next thing is that basically one can check that directly check that this p and z actually satisfy the definition of Legendre polynomial. Okay, so if you do this, then this can be written as the d over dt. So actually this is a total derivative, so this term can be evaluated as 0, right? If you take a proper integral, proper counter integral. And one can actually also show that if you pick up z, if you can do analytic continuation to get a second kind of Legendre polynomial, right? But this is not our purpose. So our purpose is just try to write down the complex integral analysis for this p and z. Okay, and I will see you guys. That's it. And I will see you guys in the next videos.